would like to do here is to use these principles of constructor theory to address the problem. And we'll see that this is extremely helpful in the case of a problem which cuts deep at the foundations of physics right now, which is the problem of merging the two fundamental pictures of reality we currently have. Quantum theory on one hand and general relativity on the other. Okay? So, to explain this problem more closely, I will need to make a detour in quantum physics. And I'll introduce a number of properties which are useful for our discussion. So, the first thing you probably encounter when you understand quantum theory and you study it in textbooks is this thing called Heisenberg uncertainty, which is slightly misnamed, and this is a nice thing that I think I learned in discussions with Arthur. So, you can take a photon as a typical quantum particle, and in quantum theory you can say that a photon can be in a quantum superposition of two different locations, two different paths. And how do you create that? Well, looking here on the left, the photon goes into a beam splitter, which is a particular kind of instrument, and the photon is split into two different paths, and at this point it's exactly in this state, which can be described in quantum notation at 0 plus 1. Which means, well, as we know, we can't quite say what it means. It's not that the photon is in both arms, it's not that the photon is either in 0 or 1, but one thing we can say is that the photon, when you check where it is at this stage, well, it's unpredictable where it is. So you sometimes, if you observe it, you will see in 0, in path 0, some other times in 1, but it's unpredictable to say which position it has. On the other hand, when it is in a superposition of this kind, there are other observables that are perfectly predictable and deterministically predictable, and that's the quantum feature about the photon. And we can see it on this side, on the right side here. This is an interferometer, and it consists really of doubling the first instrument here. So you've got one here, and then you've got two mirrors, and the photon recombines in the second such instrument. And very interestingly, at this stage, you always see the photon in one port. So the outcome at this stage is predictable, completely predictable, deterministic. And the reason is that you are actually measuring a different observable of the photon, not the path, but related, let's say, to its energy. And this is, of course, what Heisenberg uncertainty is all about, the fact that there are different properties of the quantum system which, when one of them is sharp, the other one isn't, and vice versa. Now, the other aspect of this duality is the possibility of entangling two particles, which is a chiefly quantum feature. And, well, this is one of the standard schemes that you can use to describe what happens when you entangle two particles. This is, for example, one photon and there's another one. And they are in a state, at this stage, which can be described as a state which has special types of correlations which are proper only to quantum systems. And what you need in order to follow the rest of the talk is just that